Homework 1.5, Quadratic Equations, Video 3, homework due Saturday, May 16, 2020. It dawned on me as soon as I ended the last video that I forgot to tell you which homework problems to try that are along the lines of solving quadratic equations by factoring. So better late than never. For the first two videos, you should go into homework 1.5 and try questions 1, 2, 3, and 4. So now that I've got that written down, this is out of the way. And I want to move on to the next video about solving using square roots. This will be part 1. And I'm going to change this problem slightly. I'm going to put a, what do I want to put there? Let's put 25, yeah. Okay, so we've seen one technique for solving quadratic equations by solving by factoring. Get them equal to 0, get them factored, set each factor equal to 0, and then finish solving. But in that 4-step process, the second step is assuming that the thing's going to factor in the first place. That's not always the case. For example, let's take a look at this first example. Solve x squared plus 7 equals 25. And you might be asking, where's the x term? Well, this one doesn't have one, but it's still quadratic. Highest power is x squared. If we tried to solve this by factoring, we would run into a problem. Because to solve this by factoring, we would start by getting this equal to 0, which we could accomplish by subtracting 25 from both sides. I'll tell you up front, this is going to be a train wreck. We'll go back and do something different. But if we combine the positive 7 and the negative 25, we get negative 18. And you might be going, aha, difference of squares. Go watch the factoring review videos if you don't know what that means. But the problem with that is that 18 is not a square. If it were 16, sure. And it was going to be 16, but I didn't want this to be factorable. So that is prime if you limit yourself to integers. So how can we solve it if we can't get it factored? Well, some of you might be thinking, I wasn't going to factor it in the first place. I would have taken a different approach. You see, there's something about this quadratic equation and the one over there that is different than the previous ones. It's how many x terms you see. I only see a single x term here, it's x squared. And I only see a single x term here, it's 3x. If you're solving an equation, your primary objective is to get the x by itself. And if there's only one of them, you can usually accomplish that by getting rid of all the numbers attached to it. So instead of getting this equal to 0, let's see if we can just get the equation solved by stripping down the x. So if I wanted to get this x by itself, I have to get rid of the 2 and get rid of the 7. And which one should we get rid of first? The answer to that, in short, is the 7. But the long version of the answer is you do the order of operations backwards. Please excuse my dear Aunt Sally. If I were doing this problem, I would square it and then add 7, but I am undoing it, so I have to undo it in reverse. So since 7 is the last thing I would normally do, it's the first thing I have to undo. So let's subtract 7 from both sides and get x squared equals 18. And now we have to square root to get the x by itself. Now here's where we have to be careful. Let me step to the side and just pretend it was a 16 for a moment, because there's a point that's going to be easier to make if we can square root this number. What can you square to get 16? 4. What else can you square to get 16? Wait, there's another number? 4 times 4 squared is 16. Well, what else can you square to get 16? If you can't think of it, you're only looking on the right side of 0. Negative 4. So this equation has two solutions, 4 and negative 4. I don't think we're going to disagree with that. But if I just break out a square root and cancel the square and square root the 16, I only get one answer. But it has two answers. I have to get both of them. So as part of the process I'm about to show you, when you square root both sides of an equation, you have to use a plus minus. Because otherwise you don't get both solutions. So if I do that over here, if I square root both sides of this equation, I get x equals, and I have to use a plus minus. Unfortunately, using the plus minus is an easy thing to forget, because there's not much here saying, now, use the plus minus. But what about the square root of 18? Well, I can't square root the 18, but I can break it into two pieces and square root a part of it, because I can break 18 into 9 times 2. And I know the square root of 9. The square root of 9 is 3. Don't know the square root of 2. So we get two solutions, plus or minus 3 times the square root of 2. So what's our steps for how to solve using square roots? How to solve using square roots? Well, our first step was not to square root both sides, but to isolate the term with the square. So step 1, and this isn't always necessary, so we'll start it with the phrase, if necessary, isolate the square. In other words, ask yourself which part of the problem has the square on it and get rid of everything outside of it. In this case, it was the x. Second move, square root both sides. Now, as a consequence of this, two things happens. Number one, you cancel the square on the right side, but you use plus minus on the other side. That is easy to forget. Canceling the square, that's obvious. We're trying to get the x by itself. But remembering to drop the plus minus on the other side is a mistake that the best people will make if they're not paying attention. Now there's a third step. It doesn't look like it because that problem is over, but let's start this problem and then I'll show you what that third step is. Solve the quantity 3x plus 1 squared equals 100. Now, if you're thinking, can I FOIL this, get it equal to 0 and do all that? Yes, you can. But there's something about this problem that says don't. The something about this problem is that there is only one x term. In fact, I'm going to go back to the title of this and put a note. Only do this when there is one x term. Now it might be x and it might be x squared, but if you only see one x and it's quadratic, remember that means power is 2, then you can consider solving using square roots. All right, so let's do the first move here. If necessary, isolate the square. Who has the square? Hint. The answer is whatever's immediately to its left. So the thing that has the square here is the parentheses, and whenever it's the parentheses, that means it's contents. So the 3x plus 1 has the square. Is there anything outside of that on the left side? Nope. So I can skip step 1 and go straight to step 2, which is hit both sides with the square root. On the left side, the square cancels. And on the right side, use a plus minus. Square root of 100, of course, is 10. But unlike the previous problem, we're not done. Why? Our goal is to get the x by itself, and it's not. And how many equations is this? Hint, it's not one. It's 2 equations. This is shorthand for 3x plus 1 equals 10, and 3x plus 1 equals negative 10. So at this point for your third step, if you're not done yet, and you'll know when the x is by itself, split into 2 equations and finish solving. Here I was done. It said x equals, it's over. Now if I wanted to, I could split it into 2 solutions. I could say x equals 3 times the square root of 2, and it also equals negative 3 times the square root of 2. But if you're not done, because the x isn't by itself, you're probably better off writing both equations. 3x plus 1 is equal to 10, and 3x plus 1 is equal to negative 10. Because when you start solving this, that 10 and negative 10 are going to start looking different. Starting with the first move. I subtract 1 from both sides of the first equation, I get 3x equals 9. But if I subtract 1 from both sides of the second equation, I get 3x equals negative 11. So now the two 10s look totally different. Divide by 3 here, I get one solution of 3. But if I try to divide by 3 here, negative 11 won't divide by 3. So I can just write negative 11 over 3. So when you're solving an equation using a square root, number 1, make sure it's a good time to do it when there's only one x term. isolate the square if necessary, hit it with the square root on both sides, which will cancel the square and bring in a plus minus, cancel the square, bring in a plus minus. I guess technically I should put it the minute I drop the square roots, but as long as you remember to bring in the plus minus, you're okay. If you're done, but if you're not, split it into the two equations it represents and solve each one separately. So pretty straightforward, and frankly a lot easier than, say, busting this open with the FOIL problem, because it is a FOIL problem, getting it equal to 0 and then attempting to refactor it. Because the factoring would be a little tricky. I know what the factors would be based on the solutions, but let's not go down that path. I'd like to do one more video showing a couple of examples using square roots to solve quadratic equations, because I'd be lying if I said they were all this straightforward.